everyone. This is Joe Armstrong. I opened up the lines and started things. We are having a lot of people joining right now, top of the hour, so we're just going to wait a minute or two and get everybody settled. In the meantime, a few things, I guess. Well, maybe I'll wait until everybody's here before I start talking about where presentations are at and stuff. All right, let's see. We still have quite a few people getting on here. Just want to let you know that we'll get started in a minute. Let's see, I'll go ahead and show my screen now. There. Okay, let's go ahead and get started. Hello, everybody. This is Joe Armstrong and the August Power Systems Virtual User Group webinar. Welcome. And today, a couple of things to go over before we get started on the webinar. First of all, I want to talk about the IBM Technical University that's coming up in October. I always like to push these because I think it's the best conference that IBM puts on for technical people. So lots of sessions, much like you hear on these webinars. And if there's any chance that you can get permission from your employer or whoever you need permission from to get there, I strongly suggest it would be a great time for you. So on the Power Systems VUG wiki site, I do have a discount code that's right here, TUHVUG. Is a discount code that you can use, gives you this price of $20.95. And I think that's kind of like the super early bird pricing, but this discount code won't expire. So use this code, and it's in Hollywood, Florida. All right, so the last one was in Florida too, 2 of them in Florida. It's a little strange for IBM on these kinds of things, but I'm happier to go to Florida than I am Las Vegas. So Hollywood, Florida, October 15th to the 19th. So definitely worth getting there if you can, and lots of awesome speakers that you can learn from while you're there. So I wanted to talk about that. Also, just a couple of things before we get started. I do have the presentation out on the wiki site. Oh, maybe I put that away too quick. Presentation out on the wiki site here. You can go here and download the presentation. It's in a PDF format. It won't be exactly probably the exact charts that I'm going to go through today. There's maybe a few extra in there. There's definitely some backup charts in there. So when you're all done, you want to go in there and I'll kind of reference them as I go through today. Some backup charts that have more detailed information than just what I'm going to present here. All right, so go here, and the wiki site has all the past sessions and replays for all of them. So I will put, I am recording this, so the recording is on, and I will put the replay up there when I get it. So there we go. I'll put that away. And today, we're going to talk about the IBM Power9 family. So IBM announced the first Power9 back in December. And we've kind of rolled out some things. I did a session in February on the Scaleout systems. And then we announced some other systems since then, and most specifically the enterprise systems were announced this month. So I'm going to kind of do a little bit of an overview clear back to the earlier Power9s. We'll kind of cover the entire Power9 family, but we'll not spend a whole lot of time really at all on what we've already talked about, and we'll get to the enterprise systems, and we'll spend a little bit more time on what we're covering or what's new. All right. So let's see here. There we go. So have to start out a little slow with the processor technology roadmap here, and we've dropped off. We got down to Power 4 here, and you can just see the kind of the progression that IBM has done of the Power chips, the CPU chips. The technology here, where we're back in Power 4, 180 nanometer, and now we're at 14 nanometer with Power9. Sometimes we've come out with plus chips, like Power 6 Plus, Power 7 Plus. In Power 8, we didn't call it a plus. We just added the NV link to the chip. But with Power9 is what we're going to talk about today, and we are working on Power 10. I know there's already been a lot of work done on Power 10. And so, you know, IBM's been pretty strong every few years coming out with a new power technology, keeping up with what's happening in the industry, and leading in performance and reliability and all these things that make Power just such a great platform. So just want to let you know that's continuing, and that we will be getting to Power 10 as well. All right, so let's see. So with the Power chips, we had a little bit different here, and we talked about this with the scale out, but I just want to make sure everybody's aware of it, that we have two kind of ways that we configure this chip. So in in certain systems, and in particular the open power systems, the Linux only boxes, we have SMT4 chips, and we split those cores and we make 2 cores out of it. So where we have 12 cores on a chip that can run 8 threads, that's SMT threads, 8 threads on per core. In the SMT4 and these split chips, it only runs SMT4, but you get twice the cores. All right, so in the scale out systems, we'll see that we have both. In the enterprise systems, we don't have the split core, right? We only have the SMT8 cores. So as I go through here, I'll kind of talk and you'll see which are which, all right? We also have 2 memory architectures, and we talked about this in scale out. We have a scale out memory architecture that's direct attach. We went away from buffered memory for the scale out, really as a cost savings measure and to lower the price on these. Still gets awesome memory bandwidth, and we put a lot of memory in there. We're using industry standard DIMMs instead of custom DIMMs. With the enterprise, we still use buffered memory. We'll talk a little bit because there's kind of a difference between the E950 and the E980 on the type of memory that they use, but they both use buffered memory. They get the RAS characteristics of the buffered memory, and they get, particularly with the lane sparing, and they get a little bit better performance with the buffered memory as well. So the difference there. And then the other thing that we did in Power9 is we went to PCIe Gen4, which it's kind of standard for IBM. Every time we come out with the next Power, there's usually another PCIe Gen available. So we've gone from 1 to 2 to 3 to 4 for each one. And it usually basically it doubles the bandwidth for that particular technology. So in Power9, we doubled the bandwidth. We're going to PCIe Gen4. And you can see on this little chart here in Power 7, we used to put a GX bus in between. In Power 8, we went directly attached to the chip, to the processor chip, and in Power9, we keep the same thing. So industry leading Gen 4 technology there, double the bandwidth, helps with the speed, and you'll see all the performance numbers as we go through here. So let's start talking about the Power9 family. You know, back in the day, back when I started anyway, we all had mission critical data intensive workloads. That was really what you ran on these systems. Since then, people have started to realize that they're collecting just an enormous amount of data, and that data is valuable. And we started looking for the value on that data by doing big data workloads, crunching through that data. And that takes a little bit special system, so we've developed some special systems for that. We're going to look at those. Even more recently, machine learning, deep learning, artificial intelligence has really come on the scene in a big way. And I'll tell you, almost all big companies are really looking at this, and even lots and lots of smaller companies are looking at what they can do with AI. It's just a huge market these days. And so IBM has also gone in and made some special systems that work in this space as well. And we'll cover all of these as we go through today, all right? This is our Power9 roadmap, so you'll see everything here on this roadmap that we're going to talk about today. What I'm going to do is start on the left here where the older systems are, and I'll kind of work my way to the right. One thing to read this, you'll see in the blue boxes, this, and this one over here that's associated with 950. These are all the ones that use the SMT8, the full cores on the processor. These ones in the green boxes, these are the systems where we split the core, and you can use the twice the number of cores on the system, and they're running SMT4. Right, and those are really the Linux boxes. Linux really takes great advantage of that, more cores with less threads. So that's why we did that there, and we'll see as we go through here what each of these boxes is really used for. So let's go ahead and start at the beginning, and with the AC922. So the AC922 is our first Power9 system, came out in December last year, and it has GPUs in it that are really used for the artificial intelligence, deep learning, machine learning kinds of applications, really for training this models and making those models. The AC22 is really designed for AI. It's designed for pushing lots of this data through, training these models, and let's look at and see why it does that. So back here in Power 8, we had PCIe Gen3, as I mentioned, and we'll call this 1x as far as bandwidth working within the system, okay? If you go back further, it's certainly slower, but we'll just use this as a standard. In Power 9, we went to Gen 4, so we doubled that, all right? In Power 8, we added NVLink to talk to the GPU. That was like a 5x improvement. Because the NVLink is so fast. Everybody else, and what IBM did before, we used the PCI path between the CPU and the GPU. In Power 8 NV, we did use the NVLink, and it makes a tremendous difference because these GPUs don't work on their own, you know. They get their instructions, they get their data from the CPU. So this pipe right here makes a huge difference. So with Power 9, then in this AC922, we went to NVLink 2.0. So we increased that pipe even more. We also put an accelerator in there. So not only do we have this high bandwidth, we give the GPUs coherent memory access to this, to all the memory that's in the system. So a huge efficiency in what can be done here. And we'll see here as I go on, it makes a big difference in the performance that you get out of the systems. A couple of things here. One, 5.x more data throughput versus what everybody else does with PCIe Gen3 between those systems. And I'll tell you, everybody has NVLink in their systems if they're using GPUs because the GPUs between each other are talking via NVLink, all right? But nobody else is doing NVLink between the CPU and the GPU, and that's where this comes in, all right? Plus, we have 2x the bandwidth because we use Gen 4, PCIe Gen 4, and we have more memory in our systems with the 2 terabytes. So all of this really makes the AC922 just the top of the line for doing AI. And you can see it in the performance here. It kind of shows typical system in this particular training of a large model, 3.1 hours, 49 minutes on an AC922, 3.x faster. And I tell you, this is conservative, guys. I've seen up to 56x faster different things on Power9 on the AC922 compared to what other systems can do as far as training models. The training of the models makes a huge difference. If you're in this space and you're working in there, you know that you don't just train a model once. You train it, you test it, you do some things, you go back and you retrain it again, and you might go through hundreds or thousands of iterations of this. And to get that time down just makes a huge difference. The more you can train the model, the more accurate it is. And you measure performance in the AI space with accuracy, not really how fast it finds something, but how accurate it is in figuring out what you want it to do. And the ability to run through more models, more training really gets you there. So that's what you get with the AC922 and all the advantages of it. So let's take a little look at what these systems actually look like. So they're 2U systems. What we came out with in December fits in a standard 19-inch rack, 2U, up to 2 cores in the system. All right, so 22 cores per socket because we use the split core socket. All right, so it's not just a 12. So each of these sockets has 22 cores in it, and 4 Volta GPU processors. So the Volta processors, just these GPUs, they have over 5,100 CUDA cores in them, and I think 640 tensor cores in them. So there's a lot of processing power in each of the GPUs. So you get 4 of them in this one that we came out in December, 2 terabytes of memory, some PCIe slots. All right, and this is a BMC, a baseboard management controller system in there, so not the FSP that we have in some of our other systems. So, and it runs Linux only, right? So what we came out with then this year was an upgrade to the processor. So you see this is a GTG. We came out with a GTH. Really all this is an upgrade to the processor, some enhancements to the expanded I/O in the processor and the OS. So there's a no charge upgrade between these systems. All right, so you can get the new processor and put it in the system for no charge. If you bought a system that's a GTG, you can upgrade it if you want. All right. Then what we also came out with this year is the water-cooled version. The water-cooled version can go up to 6 GPUs in it, and that's a picture over here on the right-hand side with the water-cooled version. Kind of cool in there with all the little things, and might make a guy a little nervous running water through all those electronics, but as we'll see in one of the later charts, there's a lot of use in this. So let's look at a schematic here. Just to kind of show you, I like to show these because it kind of shows you where everything is connected. The coherent memory access, which is a big deal in these systems, is really, we added this Mellanox fabric in here, which allows the GPUs to have coherent memory access. And I got to tell you guys, especially for really large models, and if you ever, back in the day, nobody thought, why am I going to need a 1 terabyte drive in my system? Memory was really small, and you lived with that. And now, God, you couldn't live with a 1 terabyte drive. And it's the same thing on this. We're going to see AI just exploding, and what the model's getting bigger and using more memory. And this coherent memory access and this large model support is going to be huge. So we have this, and this just kind of shows you where everything is connected. But I think my last chart here on the AC922 just shows a prime example of its usage in the Summit program, the fastest supercomputer in the world, made in America, up of these AC922 systems. And they're all water-cooled with the 6 GPUs in each one. And 4,608 compute nodes. So this is, I've seen some other pictures of this besides this one, rows and rows of racks of these systems. And very cool, and all done by your US government, right? So let's go to the next thing then in that chart. After the AC922, we came out with early in the year, the Power9 Scaleout Family. So probably the most popular, the systems in the Power9 family. And I'm not going to go through all of these because I really covered these in the February Power System Virtual User Group. If you missed that, go back. There's a replay back there. Go listen to the replay. You'll get all the details on every one of these. Let me just take a few minutes and talk about them overall. We have the 2 systems, the 922 and the 924. Probably the 2 popular systems. So we come in both a 2U and a 4U. They're all 1 or 2 sockets. Really the only one that's strictly a 1 socket is the 914. The rest of them, all 2 sockets in them. You can populate 1 or 2 in there. So we have the S models, which are the scale out models. These are the popular ones where you're running AIX IBM I, or Linux. They all run Power VM, okay? Or you can get the L model of the 922. It's a Linux only. It still runs Power VM. All of these run the full core, so no split core in any of these models, okay? And then we have the H models, which are the HANA models. So these systems are specifically for HANA. Now, the hardware in these is exactly the same. The only difference is that we limit it to HANA only, except for you can run up to 25% of the cores as AIX or IBM I. So if you buy a system and you're running HANA on these systems, but you're not using all the cores, well, you can use those other cores for AIX or IBM I, and this has been a problem in the past. So it's a great thing that IBM is allowing on these now. All right. So instead of going through all these, I'm just going to spend a little bit of time and talk about the S924 specifically, because they all kind of have a lot of the same attributes. So let's just take a look at some of those attributes here. So this is the S924. It's a 4U 2-socket system. It comes in 8, 10, or 12 core. That applies to most of these systems. All right, there's a 4-core option in the 914, and it doesn't come with the 12-core option. So you can see, but it's pretty much the same. So the deal is that these systems all have a smattering of PCIe Gen3 and Gen4 slots. In the 924, there's 11 of them. Some are Gen4 and some are Gen3. So if we look at the schematic here, you'll see that the Gen3 slots really come off, and we have this expander, okay, that comes off of a Gen4 out of the chip and then expands into several different Gen3 slots. So just kind of note this, that there's both in here, which really isn't a problem. There's a lot of bandwidth in this system. When we get the enterprise systems, we'll see that's a little bit different, okay? They also have 2 25 gigabit ports, not being used right now. They're really in future for OpenCAPI, future enhancements to the system. So really don't need to worry about those. They all come with different backplanes for drives, internal drives that you can put in the system. You can split the backplanes and all of that. What's new for Power9 is they also come with 2 internal NVMe flash boot adapters. These adapters take the place of those SAS adapters for the drives. Okay, so let's just, I think you can see this a little bit easier on this chart. So this is where those 2 SAS adapters plug into that drive the internal drives. And if you use the NVMe, you replace those with these NVMe. And the NVMe adapters have 2 NVMe drives on each one, so up to 4 NVMe drives. They're independently assignable to the LPARs. All right, so even though they're on the same adapter card, it's a by 16 card, and each of these has by 8, or is it by 8 and 2 by 4? But they're each independently assignable. So you don't have to worry that they're on the same adapter. They have to go the same thing. So you got 4 internal drives or NVMe. The downside, they're not concurrently maintainable. They're stuck inside here. They're plugged in like this, right? You're not going to pop this top open and pull them out and fix them while the system running. So not concurrently maintainable. Just want to make sure that's well known. The other thing is no DVD drives in any of the systems. Power9 has gone away from DVD. All right, we've replaced it with USB. So from now on, you want to do upgrades, you want to do media, use USB sticks. You can get an external DVD. It's super cheap. I think it's $100, and it plugs in using the USB port. So there's USB port on the front of these systems. Don't use the USB port on the back. It doesn't have the required power to drive your DVD. So plug it into the USB port on the front of the systems, okay? So let's see. This next chart kind of shows the different internal storage options. As I mentioned, you have the split backplane, we have the dual write cache backplane. This is the same for most of the systems. It's not exactly the same for all of them, but you get the gist of what the scale-out systems are like. And it has the internal NVMe card. This is kind of a graphical little picture of it, and that's sort of what it looks like. Each of these little things here being independently assignable drives, okay? Little table up here I put in here because as you're talking about SSDs and as you're talking about even these NVMe cards, they all have what we call a drive write per day. This is how often you can write to that card before you start using up the cells, because you know with this technology, as you write to a cell, you can only write to it so many times. And a drive write per day is you can write to that particular drive the entire capacity of that drive once every day for the lifetime of that drive for whatever its warranty period is, all right? So if you're going to use SSDs and you're going to use them for data, and not like just boot drives, but actual data drives, you want to get something with a high drive write per day. So you want to get these 10 drive write per day. So as you order these, just make sure that you're getting ones that, if you're going to use them for data, that you have high drive write per day on them. You can run HANA on any of the systems, okay? The H models will really be probably marketed and priced a little bit more specific for HANA. So if you're really just going to do HANA, you can run it on anything because they'll all run Linux. But the H models might give you a better pricing advantage, and that's why we have the HANA models. I'm just looking at a couple of the questions here. The 922 has an asterisk for IBM I because the 4-core 922 does not support IBM I. All right, so if you want 4 cores, the lowest number of cores for IBM I, you want to go with the S914. The 4-core 922 does not run IBM I. Let's see. Let's go. So that's really the scale-out servers. And as I mentioned before, I covered all of the scale-out really pretty in-depth in the February webinar. So you can go and grab the replay and look through there if you missed it before. And that explains everything about them. So the next one in our timeline was the open power systems, all right? And we didn't really cover these, so I want to talk a little bit about them because they came out after the regular scale-out systems were announced, and we really haven't talked about much since then. So as you know, IBM started the Open Power Foundation several years ago with 4 other companies, and so there were 5 companies in that foundation. Now there's over 340 companies in the foundation, and they all kind of everybody contributes and takes away and helps to develop systems. So IBM can't invent everything, and they certainly can't make everything that's invented in this technology. So this consortium really kind of helps with that. So some of the things that have come out of here is what we call our open power servers as well, and these really fit in the big data area. These are the data crunchers of the system. This is where you're going to pack the most processors in the smallest amount of space. They fit in the standard 19-inch rack. We have a 1U, which is the densest you can get, still 2 sockets in a 1U, and we have a 2U version. They run the split core. So you're going to see twice the cores per socket in these, all right? We have a 16 core per socket and a 20 core per socket offering on these. Up to 2 terabytes of memory. You get a smattering of PCIe Gen3 slots in them, all right, and Ethernet, redundant power supplies and stuff. So these will run Linux only. They're not AIX or not IBM I. These are Linux only systems, and they also have the BMC service processor. I did learn the other day that we now have the ability to manage some of these systems that have BMCs instead of FSPs with an HMC. So if you're getting these and you'd like to manage them with an HMC, let's look into that. So let's see. These systems, as I mentioned, are for crunching big data. They have twice the performance, price performance of other systems that you can find, and I'll show you a couple of examples of that. Especially if you're using Spark, there's just great efficiency with Spark in these systems. And one of the benefits of all of this is just being able to put more people on a single system and get more done with it. All right. So let's just take a look at this one example here. This is with Spark and 4 LC922s. So this is the 2U version. All right. Compared to an Intel Xeon SP system. So what do you get? 30% more performance with this system at a lower price. Okay, so it's not just that the IBM systems are performing better, and gosh, I sure hope so with those power chips in them, but you're getting it at a lower price. In this case, almost 1.6x price performance. Open source databases are just growing like crazy as well. MongoDB being one of the most popular ones. And it's the same thing. Let's compare an LC922, in this case, just one of them. 47% better performance out of the system at a 28% lower price. I know this is a lot of marketing stuff. It's not really the technical details, but I just want to show that as we go through here, we talk about the technical stuff. It's not, you're not buying this at a higher price. You're getting this at a better price, better performance, and a 2x price performance is pretty big on these. So you really want to look at these, guys. You want to pay some attention to this. Let's now, I'm going to glance a little bit at the questions here and let's see what we got here. The 914 tower, still the only box that runs 110 volt. I think the 914 rack will also run 110 volt. Not positive on that, but I do believe that I did see that. All right. Let's now move to the enterprise systems. So what we announced in August, on August 7th, was our enterprise systems, the E950, the E980. We also threw up this particular chart. They didn't really talk about it. The H950 and the H980. Gosh, can you guess what that is? Yes, we'll have HANA versions of these systems. We had kind of HANA versions of the Power 8 systems as well. We didn't call them specific HANA models. We just had, when we configure one, you could go in and configure a special edition that was a HANA edition, and that gave you a price performance or a price break on that. So I expect that they'll do the same with this eventually. I was told that we will still offer on these H950s and H980s the ability to run 25% of the cores as IBMI or AIX. Note though that the 950 does not run IBMI, so you couldn't do IBMI on that in either case. All right. So let's just take a little bit better look at these. So again, we announced August 7th. The 950 actually G8 already. It G8 on August 17th, so generally available August 17th. We're going to look at, we have different ways of rolling out the 980. We're going to have a 1 or 2 node version of the 980 on September 21st. It will be available. To get the 3 and 4 nodes added to that system, you have to wait till November 16th. And this is really just a testing. They're testing as fast as they can to make sure that everything's working fine. So it's kind of a rollout. We'll see some other things rolling out as well. We're going to go through each of these in kind of detail, so I won't really do it here. Let's start with the E950, kind of starting slow and growing up. First of all, it's kind of a redesigned backplane. Nothing really big happened here. A little bit of a redesign around the cooling enhancements. Also some increased RAS. We actually made the voltage regulators froze. So if there's an issue with the voltage regulator, the whole backplane doesn't need to be pulled out and replaced. It's just a froze, so you can pull it out and put in a new one. We didn't hear about voltage regulators as much before, but kind of voltage regulators with the whole, they've kind of come into the discussion, not just because of this, and we didn't do this for any particular reason that I know of, but with the whole dynamic frequency going on here, and we'll talk about that in a little bit. The voltage regulators come into that a little bit as well. So increased bandwidth and efficiency in there, Power VM. We actually add Power VM to all our systems now. I think that's a great thing. Power VM Enterprise Edition should just be standard out there and everybody should have it. Active memory mirroring for the hypervisor is optional on this system. You couldn't get that on any of the scale-out systems, any other systems before this. So as you know, the hypervisor is down in the bottom of the system. It's what's running the system. It's what's moving the workloads around between the cores and making sure everything's going right. And it uses memory and it uses CPU. But if you have a memory issue with the hypervisor, that whole system is going to come down because nothing else runs. I mean, if you get a memory issue on an LPAR, you might lose that LPAR, but on the hypervisor, you'll lose the entire system. So active memory mirroring mirrors that memory. And so if there's a memory issue, you know, some issue with a DIMM or something, it goes to the backup and everything can stay up. So it's a RAS issue, a reliability, availability, serviceability issue. And it's optional on the 950. All right. What's bundled with this system, you get some bundling with cloud management in all the systems in these enterprise systems now. We automatically put it in. Sometimes you can take it out. So if it's a pay for thing and you don't want it, it can be taken out, but it's in there. Capacity on demand. Our enterprise systems, if you're familiar with them, and like 750, the 850, and now the 950, all have capacity on demand. You can buy, for example, let's say you buy 48 cores in the system and you only need 30 right now. So you pay for 30 cores of licensing, and you'll actually pay for activation of 30 cores. And then later when you want to grow that, you can activate those cores and buy licenses and everything for them. So it's a great growth feature that you can put on the system. The 950 also comes with Power to Cloud rewards. We'll talk a little bit more about that later on, and because they're a little bit different between the 950 and the 980 and what they give you. So I'll talk more about that. And the Cloud Management Console is some cloud console that allows you to manage systems in the cloud, whether they're in a public cloud, private cloud, and I think I have a little bit more on that later too. Again, it comes bundled with this, and you can take it off if you need. So the 950 is a small tier. Isn't that great? It's a small software tier, so you're paying only for a small tier licensing, and it comes with 3 years, 24/7 service. So the little asterisk means that it's really a 1 year 9x5. But what IBM has done is build into the hardware price 3 years, 24/7. So essentially, you're getting 3 24/7 warranty on this system, which I think if you're using a 950, you probably want that. So let's just take a little bit deeper look at what's on the right there. Again, fits into a 19-inch rack enclosure. A little bit different processor cores on this system in that we offer the 8, 10, 11 now, or 12 cores per socket. We're going to see this on the 980 as well. And, you know, I'm not sure that I've heard any great people's explanations of why we went to 11, except that I think, you know, all these cores are different. They're all unique. It's kind of like a fingerprint. Everyone's a little bit different as it comes through manufacturing, right? And they don't always all work on a particular chip. And so I think going down to 11 gives us more chips that we can use. And two, it gives you more granularity when you order these. So we're offering that as well. So a whole 16 terabytes of memory on a 950. That's huge. You get 920 gigabytes per second of bandwidth on the system if you fill all of it. All right, that varies depending on how many you fill. Right, 10 PCIe slots, and we're going to see here, while they're all PCIe Gen4 slots, there are a few that are only 8 lane, but 8 of them are 16 lane slots. So all of them are Gen4 though. And the little schematic over here kind of shows you how they're attached to the different processors. I like putting these schematics in there so that when you're actually filling your PCI slots, you can tell, you know, which ones are going where. There's a little bit better picture later on that lays out exactly what slots are which in here. So you'll see that, but you kind of want to bounce between these and look at them. What these have in them, 4 25 gigabit external ports. These are again for OpenCAPI, not really being used right now. Probably the big thing, the really different thing in these systems is the NVMe. Again, NVMe shows up very fast, new technology. It's kind of replacing, you know, all your SSDs and stuff. It's all kind of built on the same technology. The spinning drives are slowly going away. Everything else is coming down in price, and so it all works as well. These are different from what's in the scale-out systems. These are what's called a U2. And if you were on the webinar last month, we talked about NVMe in detail, and you'll note that there's different kind of form factors associated with them. These are U2, U.2. So they 7 millimeter in height. They look like a tiny little SSD almost. So they plug in more like an SSD. They're not, you know, this DIMM type looking card. They plug in on these systems. I think on the 850 they plug into the front, and they're concurrently maintainable. So you can load up your VIOS on these systems and use it, right? Let's see. Storage controller adapters use their standard PCIe slots. All right, so the drives, the internal drives on this system, instead of having internal SAS adapters, use SAS adapters that plug into the PCIe slots. So why did we do this? A couple of reasons. One, makes it very easy to concurrently maintain them, all right? Two, if you use these NVMe drives and you really mostly boot from SAN and you just want to do the VIOS on internal drives, which a lot of customers do, you can use these NVMe drives for your VIOS. They're concurrently maintainable. There's 4 of them there. They're independently assignable. So boot from those. You don't have to put in any SAS adapters. You don't have to put in any internal drives, other internal drives, and you save some money. So that kind of lowers the price, makes it concurrently maintainable, and still allows you to boot internal drives. So I think it was a great idea that they did that, kind of out of the box thinking in my view. Still no DVD in these systems. Yeah, you can attach that $100 external DVD through the USB port. And there is I/O expansion drawers. You can put in PCIe expansion drawers, and you can put in the external drive expansion drawers. 2 drawers per node here to start with, and then later in the year we'll see 4 drawers per node. Okay, for external expansion drawers. This is just a little, again, another picture of it. Shows where all the different systems are. You'll see in the front here, and I think I do have another front that shows where all the drives plug into the front. Otherwise, not really, too much else here to see, just where the memory and stuff is, which, how many of you are in there looking at that? So let's look at the processor highlights. 8, 10, 11, and 12 cores, as I mentioned. This little chart here kind of shows, let me explain it a little bit. So this shows the actual feature code for them. There's 12 core option, so the sockets have 12 cores per socket here. One-way activation, this is the activation, you activate one at a time. You have to have, at least in a system, at least 1 core, 1 socket's worth of cores activated. Okay, so if you have a 12 cores processor chips in your sockets, you have to have at least 12. 10 or 8, you have to have 10 or 8 cores activated. All right. So you'll see the frequency range over here too. We're going to talk about the frequency a little bit on the next chart, but the performance mode on these is set to maximum performance mode. We talked pretty extensively on this on the scale out versions. So I'll show the next chart. I'll talk about that a little bit more. Okay, but you'll see the 8 cores start at 360 and go to 3.8. If you go up to the 12 cores, it's 3.15 to 3.8. Okay, so your frequency range varies, and the fewer cores you have, the higher frequency you start with. All right, they all kind of cap out at 3.8, but it starts out lower. And why does it start out lower? Because you have fewer cores, and they can draw more memory, or not more memory, more power. So, and we'll talk about that at the next chart a little bit. All right. So you have to put at least 2 sockets. Populate at least 2 sockets in these systems. So right now it's either 2 or 4. They say that there's a 3 socket support coming at a future date. I have no idea when, but since you have capacity on demand, going from 2 to 4 isn't really too bad. All right, and then as I mentioned up here, you have to have at least 1 socket's worth activated. So let's talk about the power management node for just a couple minutes. First of all, when my colleague Nigel Griffith was looking through my charts for me and making some suggestions, he said, Joe, we're not supposed to use turbo or ultra mode here, and he's exactly right. So let's call turbo higher, okay? So we got this nominal mode, what we all start with. We'll call turbo higher, and we'll call ultra higher yet, all right? Just so that I don't get in trouble with Nigel or anybody else. So there's different modes that you can run the systems in, right? And there's a static power saver mode. You go into ASMI and you can put it in this mode, and it will run at a lower power. All right. I'm not sure why really you do this unless you're not using the system, or it's on a weekend and you're trying to save money over a weekend or something like that. Then there's the static nominal mode. This is just where it runs at this frequency all the time, or it can drop down if it's not doing anything. All right. Actually, this is if you have all. They don't call this a mode. They say if you have all the other modes turned off, this is what you run in. And so that's what you're going to do if you're going to run at this mode. right? Then there's this dynamic performance mode. The only system today that defaults to dynamic performance mode is the S914. And it defaults to dynamic performance mode primarily because a lot of people have these systems in their closet in a tower mode, and in max performance mode, it can be kind of noisy. So they default to the dynamic performance mode. You can certainly change that if you have an S914 and you want to run it in max performance mode, and then it will run higher. But in dynamics performance mode, it will kind of stay between this nominal and this higher, all right, primarily. And then every other system that we have defaults to maximum performance mode. And in maximum performance mode, it generally runs between the higher and the higher yet. And what's the difference is in max performance mode, it will, one, spin the fans faster, all right? And that's where the noise comes in. Those fans will run really fast, and they make a lot of noise when they do that. And two, and this is really what does it, it will allow the voltage regulators to max out and provide all the power they can to the sockets, to the CPU sockets. It's not really the temperature so much that keeps the frequency down in most data centers. It's the power to the sockets, how much power they're allowed to draw, because we can only let them draw so much power, else things go wrong in them. So it allows the max amount of electricity to flow into that socket, and that's why it will run at a faster frequency. Now, you can't just do that all the time with all the cores going full out, all right, because then it draws too much power. So where you really get to the higher frequencies is if you have some cores not doing anything, all right. If you have cores running low, slow or low, or just not doing a whole lot, then it will transfer the power, and it really does this on a socket by socket basis. It will transfer that power to that socket to turning off some cores, giving more power to other cores, and run that socket at a higher frequency. So that's kind of the power management node thing at a high level. And the key here is that the 950 and the 980 as well, because I'm not going to talk about this in the 980, will default to maximum performance mode. Okay. So enough on that. Let's talk about the memory on the Power9. I mentioned that we're still buffered memory. It uses industry standard DIMMs, but it's on buffered memory. So this is kind of the anomaly, kind of the combination between both the Scaleout, which only uses industry standard DIMMs and no buffer, and the E980, which is buffered and custom DIMMs. All right, so the 950, in order to, again, to drop this price, and this price is very competitive on the 950. I mean, it's closer to the Scaleout than it is to the enterprise, and they do that by, again, doing this to the industry standard DIMMs. You still get 920 gigabytes per second on the system if you fill out the memory of memory bandwidth, and 16 terabytes of memory. So a lot of memory in this little one node system. It's a 4U system. All right, and various DIMM sizes that you can get with it, all right? And it's all DDR4 DIMMs. You have to at least have one riser card. I think it's 256 gig of memory has to be on it. That's a minimum. 128 has to be activated. In the capacity and demand, you have to activate at least half the memory. And I have some memory plugging rules, very detailed, all how many slots or how many quads you can put in one slot and which ones you do next and all that kind of stuff. So go into the backup charts if you want to read that, all right? They're in the backup charts and you can go look at that. So the other thing with capacity on demand on the enterprise systems is you get elastic capacity on demand. And, we hear a lot about people, they buy the systems, they don't activate all the memory on all the cores, maybe because they don't need it all, and they're getting it for future growth, and that's fantastic. And a lot of people do that, and they activate them later. Just wonderful stuff. Don't see as much people using elastic capacity on demand, so I wanted to throw this chart in there and just talk a little bit about it. This is where you can turn the cores on and then off again. Instead of permanently activating them, you activate them for a day or maybe a week, at the end of the quarter or at the end of the year, or every Friday, something like that. However your business works, or you put more load on your system, you can turn the cores on, use them for that day, and then turn them off. And you pay on a day basis $5 a day. $5 a day to get 2 more processors, or actually, what do you get? Another processor and 8 gig of memory, right? for $5 a day, 16 gig of memory for $5 a day. So that's cheap, and it gives you more resources to use when you need it at that time. Now let me give you a little hint here. If you're coming up and it's Black Friday and you really need a lot, don't wait until Wednesday to call up your business partner or your IBM rep and say, hey, I need elastic capacity on demand for tomorrow or the next day, because there's contracts that need to be put in place and stuff like that. Get this set up ahead of time if you're going to use it. Right? Get the contracts filled out. Turn it on and off a couple of times. Get used to it, so that when the big hit comes, the first time, that you're ready and you know what you're doing. All right, just don't wait, because it's not going to come out well if you do. But this is a great thing, and I think more people could really make use of this and save money with it. All right. So the PCIe slots on the 950. This is the chart really that shows nicely where the slots are, and if you kind of take this little numbers on the bottom of the picture here and go over here, you can see what processor they're at. So if you're going to plug in your PCIe cards, make sure that you're kind of dividing them amongst the different sockets. You'll get better performance that way instead of putting them all against one. Of course, I got a feeling of PCIe Gen4 systems, and these being mostly Gen 4 or by 16 slots, you're going to have a hard time, eating up all the bandwidth on any of these, no matter what you plug in here. But so 11 slots, you see 12 down here. The first one's for the FSP, and then 2 through 12 then are for PCIe cards. All right. You have a couple of USB ports here on the left. I think this is the time of day battery cover here. Then you have right here power supplies, 2,000 watt power supplies, and then blind swap cassettes here. So the blind swap, these are full height, half length slots. The blind swap cassettes, that means that you can actually take these out and put them in without taking the drawer out of the box. These little cassettes kind of go in there and snap into place. So the PCI card fits in the cassette and that slides in. So that's what you want to use, and that way you don't have to take the drawer and muck around with it in order to concurrently change one of these, because they're all concurrently maintainable. So the first GA I mentioned, you can put 2 I/O drawers on a node here. Whether you have 2 CPUs in it or 4, you still get 2 I/O drawers on a node. Okay, and then the next GA coming in November, we'll be able to put 4 drawers on the node if you have 4 CPUs in it. The difference in these slots is that if you only populate 2 of the sockets, then you don't get all the PCIe slots. And you can see that back in the other diagram I showed for which sockets, which slots were associated with which processor sockets, and you can see which ones you're going to miss. But basically all these right here in 3 and 4, you're not going to get if you only populate 2 of the sockets. All right. So let's look at the storage next. And again, here's the front view of the system. So you see these big fans sitting here. These are the drives, 5 of them across the top, 3 of them across the bottom. Either they're 3 the small form factor SAS bays. All right, so you put in HDDs or SSDs in those. The 4 NVMe bays are right over here on the bottom left. The 7mm height. And so you get 4 of those, again, concurrently maintainable, fantastic way to use. You can get these as just a regular backplane, as a split backplane, or the dual write cache, all right? Dual write cache generally used with IBM I. Again, no IBM I in the E950. And I was at LUG a while ago, and I started to ask, kind of poke a little bit at this, and we didn't have IBM I in the 850. As well, and we're not offering it in the 950. And it just comes down to, I think that you either go to the Scaleout or you can go up to the 980 and run IBM I in that. But so if you're asking, no IBM I in the 950, doesn't look like it's coming. All right. External storage options. These are the external drawers that you can get for this. Again, you can get the external DVD and then the different media drawers. Okay, so this is really for you. And then here's that chart, another chart that shows what's connected to the 950 as far as topology, which slots are connected to which chip. Okay, and again, really just for your future reference. If you're plugging things in, you can go back and look at this. So here's another chart that kind of a little bit of eye chart. I'm not going to go through this, except that this is the I/O that's planned at GA, and then what's coming in the future. Again, a little recommendation from Nigel saying that these change, and so you really don't lock into this chart and say, hey, it's on this chart, it's going to be there. You know, look at econfig or ask who's ever doing a configuration for you to make sure that what you're looking for is going to be there. And if you're looking for something in the future, it's not there now, it's looking in the future, have them check with it, all right? Don't just plan and say, oh, it's on this list, it's definitely going to be there. You might want to check into it because these things change and they kind of, you know, some things get moved up. It really takes a firmware update to add these usually because that's what they put the support in for. But sometimes they drop off, right? If nobody's using it and they haven't had a request. So make sure you check. So let's talk a little bit about RPerf. And I've got a different chart that shows CPW as well, but this is just a little chart that shows RPerf. And this chart I grabbed off of one of the, I think, the marketing slides that came up. So they compared the RPerf SMT8 to the 850. C at SMT4, and the reason I did that because the Power 8s all defaulted to SMT4. All right, when you have them, you could run SMT8, but they defaulted. So they put this chart in here and they say, oh, up to 50% more performance. Well, yeah, sure, but let's look at a comparison to SMT8. If you compare SMT8 to SMT8, you're still getting 41% better performance, up to 43% better performance. So it's not just an SMT8 to SMT4. You can get good performance just comparing, you know, really apples to apples as well. I have a link down here in the bottom of the page, Power Systems Performance Report. All the RPerf, CPWs, and other stuff for a lot of the systems. I think the last 3 are in that report, so you can go look at that for the whole thing. But I did build this chart right here that shows all the RPerfs and CPWs for all the Power 8 or the Power E950 systems in the various different, you know, configurations. So you can see it goes all the way here from 446 RPerf to, you know, 1146, and then this RPerf per core on the side here, which is significantly higher than Power 8 and definitely Power 7. We'll look a little bit at some comparisons here. So in fact, if you're running Power 7, 2x performance. And in fact, I'm going to show you stuff better than 2x performance on the Power9 systems. So you can really use either plan for your growth and use the same cores and you know, use that growth, or you can cut your cores in half and save software licenses by going to Power9. In fact, you know, you can do a 64 core Power 7 Plus system will fit on a 32 core E950, right, with no problems. So better than half. Want to look at OS support, and I'll tell you again, I have a couple of backup charts that show a little bit more detail on the software stack here. AIX levels, BIOS, you gotta have to do, and then the HMC as well, which is, yeah, here it is, 920. And I have a whole HMC chart that we'll look at as well. And then the different Linux versions as well for the E950. A little bit different between the E950 and the E980. So, you know, I might tell you, go ahead and look at those detailed charts in the backup charts here. And one other thing on the E950, before we move off of it, is the plug. I think we changed plugs between the 850 and the 850C, and it threw some people. So just to make sure that if you're going to get an E950, it's a C20 connector. All right, so look at that, plan for that, and this is just a picture of the back of the system and one with some plugs plugged into these two power supplies. Apparently these two power supplies aren't in the system. So make sure you know about that. Okay, so now let's go on and move to the last, definitely not the least, Power9 system, the PowerE980. This is our modular system. I'm sure almost everybody on here is familiar with IBM Power Systems and the 880s, the 780s, 770s, all that kind of stuff. So we've gone from the 950 to the 980. You'll note a distinct lack of a 970 in here. We do not have an E970 model. Kind of when we did the C models last year, we didn't do a C model of the 870, and I think that was maybe a little bit of a foreshadowing there that what we're going to see here, and sure enough, no 970s. You can get a 1, 2, 3, or 4 node 980. These are the systems that have the best RAS characteristics, the best reliability, availability, serviceability. Again, as with all the systems, they have Power VM built into them. All right. Active memory mirroring for the hypervisor, which I mentioned was optional on the 950. It's standard on the 980. Some cloud stuff is built into the 980, just as like it was in the 950. Again, this same capacity on demand. Probably the difference here, the one thing, the 980, the E980 has Power Enterprise pools. And we'll talk a little bit more about the Power Enterprise pools. But it's the only system in the Power9 that plays in the Power Enterprise pools. It's a medium software tier. If you're going from Power 7, I think I have a chart on this, to Power 9, you can be going from a large software tier to a medium software tier, huge savings in cost. So you want to look at that. And then it's a 1-year 24/7 warranty that comes standard with it, okay? So some of the little bit more technical stuff. The KECs in the 950 and the 980 are 5U KEC drawers, right? You either get 1, 2, or 4U before. In Power 8, though, we also went to 5U on the 980. So we have 5U KEC drawers, up to 4 of them. Plus, you always need the 2U control unit. 1 control unit per E980. The control unit's holding the FSPs, the redundant FSP cards, and it has a USB port as well on the front if you're putting an external DVD on. One of the things we did in the 980s, we moved the clocks out of the control unit, and we put clocks in every one of the nodes. So this is a great thing. One, you have redundant clocks in every node, which it just increases your RAS. 2, you don't have these cabling things to go from the control unit that are carrying your clock signal to your nodes. I think that's a real benefit as well. So we have the clocks in there in every node, all right? Up to 32 terabytes total memory in this. So this is what we came out with 3Q, only 2 KECs, 2 nodes in a 980 to start with, all right? So 16 terabytes per drawer. And we had 16 terabytes in the 950 for the 1 drawer, so they're very similar, right? And they're blind swap. Difference here, the PCI cards are low profile. All right, so be careful when you're buying cards. You know, the 950 was high profile. You have I/O drawers, the PCIe expansion drawers that are high profile, full height cards. The KECs for the 980 are low profile. All right, we have cabling between the KECs is different on the 980. 4x bandwidth improvement for moving all that data around. IBM's done a lot, not just with improving the CPUs and the performance of the CPUs, but actually increasing the bandwidth and being able to move data around and get rid of these bottlenecks in the systems. And this is another way between these KECs, 4x bandwidth improvement. We also have those 25 gigabit ports available for future OpenCAPI stuff. I wonder when we're going to see some OpenCAPI stuff. I'm really excited to see what they might come out with. Again, we have NVMe in these, and once you saw it in the 950, you probably expected to see it in the 980. Sure enough, and it's the same NVMe drives are U.2 bays, and instead of being on the front, these are on the back of the systems. And USB ports integrated into the systems. Funny enough, I think I was hearing Tracy Smith talk the other day, and he said we had in Power 8 USB ports on everything until we came to the high end, and for some reason we didn't put them there. You couldn't attach things like a DVD drive, external DVD drive using USB. so you had to use PCI slots. So we have integrated USB ports, especially on the front of the control unit, really for your DVD drive. All right, and then you can put expansion drawers on here. Again, 2 drawers per KEC to start with. We'll see 4 drawers per KEC later in the year. All right, so when we get later in the year, so November, the second GA of the 980, here's what we're going to see different. All right, we've got it in blue. We're going to see up to 4 drawers. So instead of 2, we'll go to 4. Up to 192 cores in it. 64 terabytes of memory because we get 16 per drawer. All right, and then of course we're more PCI slots. Every node has 8 PCI slots. Right, we'll take a look at closer at those as well. All right, so and then be able to add more expansion drawers as well. Instead of just 2, we'll be able to do 4 drawers per node. So when we get all done with this, we're going to see later, you'll be able to put a lot of PCI cards in here. We're also going to see later on in the year, same serial number upgrades, right? So you can't do that right away. Have to wait until November for then, and we'll see some add-ons. And also earthquake certification for those that live in those kind of areas where you need that. So this is an internal view of the drawer, and there's really not a whole lot to see here, right? You got all the DIMMs, voltage regulators, and just everything in here, and wow, you got 4 processor sockets here. So it's not a lot to look at inside of these as opposed to some of the other systems maybe. So let's look at the back of the system. So on the 950, the NVMe bays are on the front. Here they're on the back, right in the middle, between your PCIe card slots. All right, so 8 slots here. And again, it's a 800 gigabyte 4K NVMe drive. You get 4 of them, independently assignable. In every single KEC, you have these. So if you have 4 KECs, you have up to 16 of these systems. All right. If you get 2, you have 8. So it gives you the option of, doing more VIOS, booting VIOS. You'll notice no internal drives in the system. And we didn't have internal drives in the 880s either, but we didn't have NVMEs or anything that we could put in the 880s or the 870s to boot from. You had to, if you didn't want to boot everything from SAN, you had to add an external drawer. And now you can boot from these NVMEs, and they're nice that they're concurrently maintainable. So, and then you can see other stuff, the USBs and clock cards and stuff that are down here. So this is the control unit. The control unit really has the FSP cards, so the redundant FSP cards. This is the only system that does redundant FSPs. And the FSP is sort of what kind of monitors and runs the system. It's what the HMC is talking to and all of that. So you also have you have cabling, all the cabling that's coming off of these systems, off the control unit to each of the systems, and then you can do your external DVD. So this little piece up there, this is not a DVD in here. This is for the system card. This is where that's telling the system what it is and serial number and all that kind of stuff. So you don't want to mess with this, and you don't want to think that this is your DVD. There's only an external DVD in these systems. And if it wasn't clear, the NVMe is concurrently maintainable and hot swappable in the 980. So let's look at the processor options. They're really just very similar to the 950. There's 8, 10, 11, and 12. The frequency range is a little bit different. All right, as you can imagine, the 12, again, starts at a little bit slower, 3.9. The 8-core option does go to 4.0. All right, and this, as I mentioned, is a medium tier, so it's an IBM I, it's a P30 group. Right, and I mentioned that the 980 defaults to maximum performance mode. It's going to go at the highest processor frequency all the time, and it's going to take all the steps it can to get there, which means it's going to run the fans faster, and it's going to give as much power as it possibly can to each of those sockets so that they can increase their frequency and run faster. All right, so the memory on this, a little bit different. When we talked about scale outs, you know, depending on what DIMMs you're using, and if you're only populating half the DIMM slots, you got a little bit different memory speed. The memory always runs at 1600 megahertz on this system. Again, you have to use at least 256 gigabytes of memory. 128 has to be activated. I didn't really talk too much about capacity on demand on the system, but it does have capacity on demand, as you can imagine. I will show another chart about elastic capacity on demand as well. 230 gigabytes per second per socket on the system. All right, and for the whole plugging rules and stuff, you can go back and look at those same rules that in the backup charts that are there for the 950. All right, because they pretty much are the same, and you have to activate at least half the memory that's installed on the system. Okay, so whether you put 2 terabytes or 4 terabytes in the system, half of it has to be active. And that's no different than what we've done in the past. So it should be kind of standard for everything. All right, let's see here. All right, so this is elastic capacity on the 980. It's a little bit more expensive. 980 is a bigger system, and everything's a little bit more expensive on it. It's a different tier as well. So it's a little bit more expensive, but instead of $5 a day, it's $15 a day for a core and 32 gig of memory. All right, so again, if you have end of the year, end of the month, end of the week kind of spikes, and you just need a little bit more resource during that time, you know, put in the extra cores and get this set up ahead of time, and I think this will be useful to you. Internal storage options, no internal disk. So it's pretty simple. You got NVMe, okay? 8 gig, each one is 8 gig and up to 4 of them. And then you can put these expansion drawers on there, okay? PCIe slots, this kind of shows where the slots are. And each of the slots is Gen 4 by 16, full bandwidth, everything. None of this, no Gen 3, no by 8. Every slot is the same. There is so much bandwidth in this system. I just can't imagine using it all up. And then the same thing as we had with the 950, only 2 drawers. Okay, expansion drawers to start with. When we get to the fourth quarter, then we'll have 4 expansion drawers, and you'll be able to put up to 192 PCIe cards in the system. And won't that be great? All right, so same thing here. Power I/O that's going to be here. Look at this chart. You know, see what's on there. If what you want to put in your system isn't on there or something, and you think it's going to be there later in the next firmware release, and this says first half of 19, check with somebody, make sure it's going to be there. Don't just rely on this chart. This came out in August. Actually, it says this, as of January 2018. This came out in January. This is old, so make sure you just check and that the PCIe cards that you're going to want are going to be there. And then this is showing what is attached to each of the chips. Again, I like these charts so that you can really see when you populate those chips that you're populating and spreading your PCIe cards out amongst the different sockets. One other thing on this, I'll just note that, you know, they put the SMP ports up here to connect to the other drawers. Okay, so this is our modular system. We have different drawers. There's 4 lines here. Well, gosh, each drawer is only going to connect to 3 other drawers right now. I heard that they actually designed this so that they could add 5 drawers. You could have a 5-node system, and then we decided, no, we're not going to do that. We're just going to go 4. So we've got kind of an extra port here that's an open CAPI bus. It's kind of for future use. But there are 4 lines up there, and only 3 of them are really used to connect to the other ports, to the other nodes. RPerf on the system. Just a little RPerf chart here. And again, I took this from the Power Systems Performance Report and just kind of built this chart and threw it in here so you can see our perfs anywhere from 910 to 5,000, over 5,000 in the CPW column here if you're running IBM I. A couple of comparisons here. Let's look at Power 7 Plus 780. So if you have 128 cores compared to 128 cores, it's only 1,380 RPerfs. That's a 2.6% improvement over the Power 7 Plus system. a 795, 256 cores on the 795 gives you an RPerf of 2978. That's a 70% improvement with 25% fewer cores. And you're going down a software tier. We're going to see here that's going to make a pretty big difference. And even if you compare it to an E880C, right, an E880C with 3678, that's still a 38% performance improvement if you're doing the highest, biggest E880C you can and comparing both a 4-node to a 4-node. So great performance improvements in Power9. And I didn't really mention that one of the things in the Power9 chip, and I think I talked about this in the scale out, but where you went to SMT4 to SMT8 in Power8, you got a little bit of improvement. And it wasn't a lot, 7 to 11%, somewhere in there, and that makes a difference to some people if you're running your workload. In Power9, when they designed the Power9 chip, they really changed the engines and the way they work inside the chip. So when you go to SMT4 to SMT8, you get a better performance improvement. There's no reason why you wouldn't run in SMT8 in the Power9 systems and use all of that RPerf. And I think you'll see it makes a difference. And with this chart, it's kind of similar to the 950 chart that I had in there. This just had the 980s in it as well, and just shows that there's just so much better performance in the 980 than there were in the Power 7. So if you're running Power 7 today, there's some great reasons that you might want to go to Power 9, and this chart kind of demonstrates one of them. You can take a Power 7 770 with 64 cores, and you can replace it with a Power 950, an E950. You get better RPerfs with fewer cores. You leave some capacity on the table for future expansion, and you can cut your cost by less than half. All right, so just to kind of walk you through here, of course, there's no hardware cost, no software licenses. You have maintenance on the hardware, and you have maintenance on the software in a medium tier. And this is kind of a sample price, okay? These prices will change for everybody, but this is a sample price, and it's pretty good. And then here's a hardware cost for that 950 with some configuration. And you transfer the licenses from your existing machine over. Your hardware maintenance is included in that cost for 3 years. And your software maintenance is a small tier. And you have this cost. And again, this cost will vary a little bit, but these are pretty good, and it's less than half. So you can imagine that you're going to get a pretty good deal out of going from a Power 7 to a Power 9. So if you have a Power 7 systems and you want to save some money, and you're doing budgeting for the next 1 to 5 years, look at this, because I think you can have some savings here. This is another kind of same kind of a thing. This is going from a 780 to a 980 to a single node 980. So 96 cores. They pull it down to 32 cores. And again, I don't want to go through this a lot, but you have a definite cost savings. And I think no matter what Power 7 system you have today, talk to somebody, if your business partner, your IBMer that you work with, and talk to them and do some comparisons, and I think you'll find that you'll get a substantial savings over a few years. So I talked a little bit about RAS, 980 having the best RAS characteristics, so I wanted to throw in this chart here, and this compares all the Power9 systems. So we're not comparing to other systems now. Let's just show if you're looking at different Power9 systems. So here's the scale-out systems, all right? And then compared to the 950 and the 980, and of course the 980, you get multiple nodes, which means if you have some failures and stuff, you still have nodes that are good, and then you have some other different RAS characteristics that make the E980 just the best, most reliable server on the planet. And this is another availability thing, and this is really showing an unplanned downtime. And again, Power Systems in general just have the best, least amount of unplanned downtime. So the highest availability, and this is just a chart that was done by a third party that shows that. So let's talk a little bit about OS. I showed a software stack for the 950. I didn't really put in this chart. This is kind of a real high-level chart, but I just want to make sure that everybody's aware. AIX 5.3, not supported on Power9, really out of support now. You can't even buy extended support anymore. So if you're on 5.3 or later, heaven forbid, upgrade, find a way to upgrade. I know people who are on 5.3 probably stuck that they bought some software and whoever they bought it from is out of business or won't upgrade or whatever. You know, that's going to go away. You're running unsupported, and hopefully you're not running your business on it. But go up to, well, don't go up to 6.1 because that's got a short, it's a short timer right now. All right, go up to 7.1 or 7.2 if you're on 8AIX. If you're on IBM I, 7.1, not supported on Power9. Same kind of thing. Go up to IBM I 7.2 or 7.3 preferably. Get up to the latest. This is the kind of basic software chart for the E980. You'll see, again, in the backup charts, I have a little bit more detail on technology levels, and if you're running using VIOS, or if you're running where you're doing a direct attach, there's different kind of TLs that you can use and all kinds of stuff in there, but this is sort of the basic high level that you need to run with. And we're going to talk a little bit more about the HMC here in a minute. So in fact, let's talk about the HMC on this next chart. On the HMC for the enterprise systems, you have 920 for the maintenance level. The scale out versions used 910. So the 910 was required for scale out. The 920 just goes on top of the 910. It's just an easy upgrade. But if you're going to have in your mix some enterprise systems, you'll have to upgrade your HMC to V9R1 920. The CR7s, 8s, and 9s are all supported. They'll all manage Power9 just fine. We no longer sell them. These are the appliances that were built on x86. You know, we've been doing that forever for HMCs. We finally said that, well, you know, why don't we just put it on a power system? So now the CR1, 7063 CR1 is on a power system. It's an appliance. So it is, you buy the HMC just like you did on these others. Comes with the hardware, the software, everything. And that's what you can get. Or you can use the virtual HMC, just as good as any other, has all the features of everything else. You can put the virtual HMC on an x86 system if you want, or you can put it on a power system. You cannot manage the power system that it's on, all right, with it. Okay, so if you put it on a power system, you have to have some other HMC that's managing that power system. So it makes perfect sense that you can't manage yourself. My manager tells me that. So that's the way it is for the HMC as well. So, but CR1 you can buy, and you can buy virtual HMC. You can use these others, okay, for managing Power9 still. So kind of as I get towards the end here, I really want to wrap this up and see if I can't do some questions. A couple of quick things I want to go through. First, Power Cloud rewards. The 950 and the 980, you get 5,000 points for the 950. 10,000 points for the 980, doesn't matter what size it is. We're not doing if you buy a 1 node, you get more, you get less than if you buy a 4 node. Any 980 you buy, 10,000 points. You turn these in for lab services engagements. I think you need to have 10,000 to start with. So you need to buy 2 950s, okay, to start with. But 5,000 for the 950, 10,000 for the 980. Enterprise pools. The 980 plays in the pools. 950 does not play in the enterprise pools. Enterprise pools are N-1. So you can have a pool with Power 8 and Power 9, or Power 7 and Power 8, but you cannot have Power 7 systems in the same pool as Power 9 systems. So if you have old Power 7 systems and you're buying Power 9 and you're going to keep them around, you can't put them in the same pool. You can move licenses from 7 to 8 and then 8 to 9, mobile cores and stuff. So look into that, but they can't be in the same pool. All right. MES model upgrades, we can upgrade from an 880 or the 880C, same serial upgrades to the E980s starting November 16th. So you have to wait till November 16th to do it, but you can upgrade these. If you have Power 7s, you have to go to Power 8 first if you want to do same serial upgrades. And then we have a new rack, the S42. You can kind of see some comparisons here. The T42 has been around a long time. The S42 is really made to fit on a data center floor. It actually has some other options too. It's a little bit deeper rack, okay? And so this particular chart here shows some racking requirements here. So the S42 here on the left. What the difference is here is you'll see on the T42, we always said you needed some open space. On these left two, it's on the top. On these bottom two, it's on the bottom. Or on these right two, it's on the bottom. So you don't need to have that open space required for the cable egresses on the S42. Not necessarily a bad thing to have a little bit of open space. The cables can get pretty tight in these systems, as you know if you've walked through your data center, but not required here. And just a couple notes about cloud. These enterprise systems, if you have a lot of them, you probably run in a cloud. Either you have a private cloud in your data center or a hybrid cloud somewhere where you have some both public and private things in public clouds and private clouds. IBM, these systems come bundled with cloud software. They're really built for being in a cloud. We have the cloud management console for managing things wherever it's in the cloud. We have the cloud private for doing your own private cloud, either on its own or in conjunction with a public cloud. We have enterprise pools for moving things around in the cloud. There's a lot of cloud stuff built into here. It comes naturally with the system, so look at that. And there's a lot of things, if you're doing cloud, I think there's a lot of benefits to it, to having a private cloud, just being able to deploy things. I think that's really what you get a lot out of the cloud. And I've seen a lot of customers that moved to a public cloud and then came back because, the public cloud looks cheaper in some ways, but when you move all your stuff there, you're paying for somebody else to do all that, and it's not necessarily cheaper. And if you got the skills, sometimes it can be better to keep it private. So, give yourself some thought on that as well. And I'm just going to stop with this chart right here. It's really the last one in the deck that I was going to go through. I'll leave it up there. I'm not going to talk to all this. Let me take a moment and kind of glance through some of the questions. Do you need a horizontal PDU on a T42? You don't need a horizontal PDU on a T42. We recommend a horizontal PDU on the T42 because of cabling. Big time cabling, especially if you're putting very much in that. So it's a very, very, very strong recommendation. And on the S42, I'm not sure if I didn't hear anything about it necessarily that we needed on the S42. Can we LPM LPARs from Power 770s to the 950s? Depending on what that AIX level is, yes, you can. As long as that same AIX level is supported on the 950, you can. So yeah, AIX 7.1 and 7.2, you can LPM. The presentation is on the Power Systems Virtual User Group Wiki. So that is, if you got any emails from me, it's got a link to that wiki. That's also, I put it in one of the first comments here, so you can do that. You can see it from there. AIX version 3 WPARs, version WPARs, no longer sold. If you already have AIX 3 version WPAR, you can migrate that to a 980, but we don't offer that anymore, selling that anymore. So if you already have it, you can use it, but just not offered anymore. I didn't say any, so I talked about IBM racks. Whether these systems fit in APC racks, I don't know. You'll have to look at the specs and see. I'm not sure on third-party racks. I expect they probably would, but these are a little bit deeper, so you want to make sure that they will fit, okay? There is no direct upgrade path from Power 7 to Power 9 for same serial number upgrades. You have to go to Power 8 first, and know that when you do that, you have to run on that Power 8. I think it's for 90 days. And this is all government regulations. Okay, so it's not something IBM's just making up, but you have to. It's because of government regulations that you have to first go to Power 8, then you have to run on that for like 90 days or something, and then you can go from Power 8 to Power 9. So and I think that's just same serial. There's some regulations associated with keeping it that way. So much of the hardware has to come over and all that kind of stuff, and you can't bring a lot of Power 7 hardware over, and that's why you have to go to Power 8 first, and that's why you have to run on it so long first. So it says, the question is, does this system support enterprise PUBL mobile COD? The 980s do. The 950s do not play in enterprise pools. There's no mobile stuff on the 950s, okay? The E950 does not have redundant FSPs. The NVMe cards can be assigned to the VIOS. They can be assigned to the same partition, or they can be assigned to all different partitions. And let's see, there's a whole bunch of questions on here I'm not going to get to, and I'm really getting out of time here. So yeah, okay. So the E950 with only 2 sockets. If the second socket fails, do the NVMe fail, and does the frame fail? I got a feeling if a socket fails, that the system is not going to be handled well. You've got the hypervisor running down there using some CPU, and you got all kinds of stuff in there. I really couldn't say what's going to happen. A whole socket failing is pretty odd, but I'll just guess the frame's going to halt. So so with that, I think I just want to point everybody to the again, the Power Systems Virtual User Group Wiki has presentation materials on it. I'll put the replay on it as soon as I get it all formatted and uploaded and everything like that. I'll put a link to the replay on it. I want to thank everybody for joining today. I'm sorry I didn't have anybody else on here, and I'm just hoping that all the sound and all the video went all right. So thanks everybody for joining. I hope you have a great end of your summer. Fall's coming fast. It's a beautiful time, but it's always sad to see the summertime go. And so have a great month, and I'll be setting things up for next month's VUG, and you'll see in some emails about it. So thanks so much, and that's it.